The MAX 66242 is an NFC authenticator, and shown here is our MAX 66242 EV kit board. On the lower right corner of this board is the IC itself, shown here in an SO8 package, and in the upper right corner of the board is a temperature sensor, the DS7505. So we now have an iOS and an Android app to exercise this board, to demonstrate it to our customers, and the rest of this video goes through the app. Okay, so the app has 4 functions selected at the bottom of the screen. This is the first one, called Basic Commands. This is used to read the 64-bit universal ID that's factory programmed into the MAX 66242, as well as turning on or off an LED that's on the evaluation board. So the next function is called Device Features, and this is about non-SHA-2 based reading or writing to the 4K bit EEPROM array that the MAX 66242 provides. And that 4K bit array is partitioned into 16 pages of 32 bytes. Each of those pages can have a protection setting that this particular function we're looking at here can apply. For example, write protect, or SHA-2 authentication protect, or read protect. By the way, once one of those protection settings is applied, it cannot be reversed, it's permanent. And again, from this tab, we can write to a page or read from a page, assuming that there's not a protection setting applied that prevents that from happening. So this function is called Cryptography, and it's used to write a SHA-2 secret to the MAX 66242, or to set the SHA-2 secret in the app so that we can perform SHA-2 operations between the app and the MAX 66242. And by the way, when we write that SHA-2 secret to our IC, it's not write protected, so we can do this over and over again. It's also used to perform SHA-2 authenticated writes to one of the 16 user memory pages that might have SHA-2 authenticated protection applied to it. And then finally, it's used to perform a SHA-2 MAC-based challenge and response authentication sequence between the app and our part. The next function is called temperature, and this is used to perform a temperature measurement with the DS7505 that happens to be on the board, and we're going to communicate through the MAX 66242 to the DS7505 to make that happen through an I2C interface. So these temperature measurements are performed, they're recorded by the app, and we can actually plot these and look at these later on. And finally, we have App Note 7448 that goes through each of these functions in more detail. Has some pointers on how to get the app from Apple's App Store and Google Play. The App Note also has information about the EB Kit board itself, some of the technical details behind it.